Hello, this is Rick from MathX, and today we'll be going over problem number 21 on the 2020 AMC 10A. Now this problem was quite interesting, as like a lot of AMC 10 problems, it made you think quite outside the box. And when I took the test, I spent a lot of time on this problem trying to think of the solution. I only got it after a long period of thinking, so that's why we're going to go over it today. There exists a unique strictly increasing sequence of non-negative integers a1 less than a2 less than ... ak, such that 2 to the 289 plus 1 divided by 2 to the 17 plus 1 is equal to 2 to the a1 plus 2 to the a2 plus ... 2 to the ak. And then it asks you, what is k? Well, to start off the problem looks kind of nasty to start with, like 2 to the 17, 2 to the 289, those are all like kind of scary looking. So I'm going to try to simplify the problem by reducing 2 to the 17 as x. From there, I can actually simplify this expression right here into x to the 17 plus 1 over x plus 1. Now I know it doesn't look that much friendlier, but people who are experienced with factoring can easily see something out of this. Whenever you get a term like x to the n plus 1, we can always divide x plus 1 out of it, and it comes out pretty friendly. For instance, in this case, x to the n plus 1, I would just factor it like this. X plus 1 times this huge other term. In this case, probably be x to the 16th minus x to the 15th plus x to the 14th minus, and you get the idea. It'll go on like that. And we see that this works because if we FOIL this out, weird terms will get cancelled out because of the minuses and pluses that are in the equation. From this equation, we can factor it out to carry the x15 on both sides. So bringing it down, we get in parentheses x to the 15th times x minus 1 plus x to the 13th, because we're factoring out x to the 13th from each of these terms, times x minus 1. And we can keep on doing this until we reach x to the 1, which is x, times x minus 1. Then we look at what we put as x. We realize that x is 2 to the 17th. So that means this x minus 1 term is just 2 to the 17th minus 1. And this is something we can use to our advantage. This takes the form of the sum of any geometric sequence. The formula for the sum of the geometric sequence is a times r to the n minus 1 over r minus 1, where a is the first term in the sequence, r is the common ratio that's being multiplied, and n is the number of terms in the sequence. If the sum of the equation is this, then we know that r is going to be 2, so that leaves the denominator as 1, meaning we can just cancel that out. Our a has to be 1 because there's no other coefficients involved, so we know it starts from 2 to the power of 0. And there are 17 numbers involved, so it probably ranges from 2 to the power of 0 to 2 to the 16th inclusive. So then all of these x minus 1 terms house at least 17 terms in each of them. And then along with that, we're going to multiply each of these 17 terms by this other coefficient, which is 2 to the 17th to raise to some other power. So in this case, it's 2 to the 17th time raised to the 15th. So each of these will also add another power of 2 sequence. So we realize that the number of 2's involved is the 17 in here times the 8 different coefficients that multiply it onto it. So we got 8 times 17, which gives us already 136. And then that would look like a tempting answer at first, but then we realize that this equation ends in sudden plus x to the 0, which cannot be factored with anything else. So we have to take account for this extra 1 in the sequence, this extra 1 that forms when 1 times x to the 0 is formed. And we just have to take it separately from all these other calculations. So we can avoid the mistake that so many people probably made on the AMC 10A when they forgot to take account for this one, giving us 137 as our final answer.